Hi guys, I'm Artem.
My name's Ari. I'm Steven.
I'm Anton.
And we're the team Twisted Plastic.
Yay!
So we're using PS2 controller to control our car, which as you can see wireless. It comes with a very handy PS2 receiver, which pairs automatically with our controller. And in order to communicate with a receiver, we just use the normal PS2 protocols, which include enable line, command line, data line, and plot line. And after you program all of that in a hardware FPGA, it sends data to this white wire, which we can read, and then analyzes data in FPGA. We mapped these two sticks to communicate with the car. This is steering, this is acceleration, and some buttons correspond to steering adjustment and others for shooting.
Okay, so when we bought this car, it came with a 5-pin servo that is slightly different from a 3-pin servo, as we have to take the values from a potentiometer to see where the wheels are oriented. What we did for this is that we kind of compared the values from the potentiometer to the values we want the car to achieve, and then we stabilized it using PID feedback control in Verilog. So that's for the steering. For the motor, we just used a simple H-bridge, but since it's a pretty large motor and it's a pretty heavy car, we kind of need a very huge heatsink for the H-bridge. So this is our heatsink. It's pretty massive, but it gets hot really quickly. So that's the motor. And then for the accelerometer, we just used the same accelerometer we did in Lab 7, which used the ADC converter inside ACE in the Smart Fusion, and that's what we did for the accelerometer.
All of the cars also have the infrared laser gun. The infrared LED that is located inside of this tube sends a series of pulses at a frequency of 56 kHz, which is encoded in Manchester encoding. This transaction includes the long start beat, the 4 beats to indicate that the information wasn't corrupted, 5 beats for the damage, and 2 beats for the car number. This IR receiver then receives this data and pulls the signal low when it sees the signal at the frequency of 56 kHz. Then we decode this data and use this information in the software.
So we built this JavaScript web app to control our game, and as you go through and select the different options that you can use to customize your car, the cars will respond with an LED light blinking that says that the person has already selected their car. And until I press the start button here, the cars are not going to respond to the PS2 controller telling them to move, and the game will not start. And let's go ahead and start the game. And this is the display that shows where every person is in the game and how much health each car has left and how many times they've killed the other cars. And this is updated in real time with this event log over here that we built using the Mac device drivers that linked to a USB port, and that USB port had an XB on it that connected to the entire game. And as soon as the XB got a signal from the cars that an event happened, it propagates that through the network bus all the way to the web app. And this all happens in real time. And we used a technique called long pulling to update events as they happen. Yeah, you can start. Yeah. So what are we saying?
Hi guys, I'm Artem.
Ari! Okay.